Greetings everyone. I have an interesting physics problem that I would like to solve with you today to mark the release of our 2000th video tutorial here on Study Force. Let's begin with a thought exercise. Imagine you're in the North Pole and you see an iceberg floating in water. The iceberg appears big on the surface, but how much of it is actually submerged underneath? In this video, I'll show you the physics behind solving such a problem. So the question reads, an iceberg floats in seawater. What percentage of the iceberg is submerged if the density of ice is 917 kilograms per meters cubed and the density of seawater is 1025 kilograms per meters cubed? And notice that I've used the Greek letter rho to represent density. That's just how we do it by default, but you can use any letter if you like. The very first thing that I want to do is assign a shape for this iceberg. And it can be any shape that you like, but what I will choose is a perfect cube just for convenience sake. So a perfect cube that looks like this and whose side length is s. And a cube is made up of squares. So all of these sides, the length, the width, and the height will be s. If we want to find the volume of this cube, the volume is length times width times height, so it's s times s times s. That makes s to the power of 3, and this equation represents the volume of the iceberg. To find the mass of this cube, we can take the density, which is 917 kilograms per meters cubed, and multiply it to the volume being s to the power of 3. The reason why that works is because s to the power of 3 has the units meters cubed, and density has the units kilograms per meters cubed, so their units would cancel out, giving you the mass. So not only do we have an expression for the volume, we also have the mass of this cube being 917 kilograms times whatever s is to the power of 3. To find the amount of force that this ice is exerting on the water, we can say that force is equal to the mass of the object, 917 times s to the power of 3 kilograms, times the acceleration due to gravity being 9.8 meters per second squared, and that's a constant. This will give us an answer, a number that is in newtons. And don't confuse the fact that this s represents side and that s represents seconds. We have an equation for volume, an equation for mass, and an equation for the force that this iceberg exerts. Next, what I'll do is come up with an expression for the buoyant force, which is the force that the water exerts on the iceberg to prevent it from sinking completely. And to calculate the buoyant force, I'll write down F sub B is equal to the density of the seawater, which is 1025 kilograms per meters cubed, times the acceleration due to gravity, being 9.8 meters per second squared, times the volume in which this cube is submerged into the water. We don't know how much of the cube is submerged into water, but we do know that a percentage of it is submerged, or a fraction of it. So what I will do is write down this expression for volume times a constant k, which represents a fraction of s to the power of 3. I'll use the letter k for constant. So k times whatever the volume is as s to the power of 3. And actually what we're looking for is the value of k. The next thing is to set this value of force, the buoyant force, which is the force that pushes against the ice cube, as 917 times s to the power of 3 times 9.8 meters per second squared. Essentially, all of this expression will go into here. And the reason why we set the buoyant force equal to that of the icebergs is because in order for the iceberg to remain floating, the buoyant force needs to be greater or equal to the weight acting downward. Anything less would cause the iceberg to sink completely. Okay, so that being said, I'll place this expression in for there. 917 times s to the power of 3. Remember, that's an unknown. and that's in kilograms, times 9.8 meters per second squared. That's the left side of the equation, and the right side of the equation will be this exact expression again. Now that we've written it down like this, some very interesting things happen. This factor and that factor will completely cancel out because you have factors on either side. Furthermore, this factor, s to the power of 3, and this factor will also cancel out, leaving us with 917 kilograms on the left side, and on the right side, 1,025 kilograms times k. The reason why I'm not including m to the power of 3, this unit at the bottom, is because it would have canceled out with the units of s to the power of 3 anyway, which I didn't write, but I should have earlier. Okay, so we have 917 kilograms on the left side, and on the right side, 1,025 kilograms times k. Dividing both sides by 1025 kilograms to isolate for this k. This cancels out with that. Using our calculator now, 917 divided by 1025 makes 0.89. 0.89, or 89% of the iceberg, is submerged in water at any given time. The reason why I find this question interesting, is because anytime you see an iceberg that's floating in water, try to imagine how much more of that iceberg is submerged in water in which you cannot see. And in this case, it's 89% of the iceberg. And another way to think about it, it takes 89% of the iceberg to displace an amount of seawater equal to its entire mass. I hope you enjoyed the video. If you have any comments, leave them in the comment section below, and I'll gladly respond to them when I get a chance. Thanks for watching.